All right, it's the 14th of May, 2024. This is Mesh Live Coding with Gimbalabs and friends. And we have been looking for the last few weeks at Asteria, which is a game project from TXPipe. And just to catch people up, this is what we're looking at right here. We decided to use these sessions this month just to try to build a demo front end for this Asteria game, to build some UI for some of the basic transactions with Mesh, to start to be able to visualize the game board. And we said that maybe we can start with these transactions. Start a game with selected parameters, mint a ship and a pilot token pair, and ideally have a player be able to move a ship. Now, Alfredo, I know we're kind of jumping in hot right here. This is what I'm bringing you into some work in progress right here. Have you heard about Asteria before?
I have not, to be honest with you.
Okay. So let me just get you guys up to speed. Give me 1 second. We'll pull this up here. All right, so here's the Git repo for Asteria. I'll drop this in the chat as well. And so what this is it's got off-chain and on-chain code. The on-chain part of Asteria is written in Aiken. That's where your Plutus validators are written. And the off-chain part uses Lucid, which is a deprecated TypeScript library for Cardano. It's being supported by some new libraries. Butane is, I think, the most reliable new version or fork of Lucid. But what we wanted to try to do here is compile the on-chain parts from Aiken, and then instead of using Lucid, use this chance to learn a little bit about how Mesh works by building the transactions listed here in Mesh instead of Lucid. So this gives us a chance to understand how the contracts work, look at compiling them from Aiken, and then it gives us the chance to do what we are actually here to do in this session, which is learn a little bit more about the Mesh libraries. Does anybody have any questions about where we're starting from this repo here and what our goal is? So 30-second review, what's Asteria? It's a game. It's a little bit like Battleship, okay? And what you have is every player in the game is navigating with a ship around a two-dimensional game board. And we can keep all the data we need about each ship in some datum. And we'll be able to look at this as we start to play with the transactions. In order to move a ship, the player needs to have a pilot token in their wallet. So the ship token is locked in a UTXO at a validator address, and the pilot token is in a player's wallet. And so player 10, for example, can move ship 10 because they connect a wallet that has the player 10 token in it, and that's what allows them to move the ship. And we've covered some of the details of these mechanics in prior sessions. Those recordings are on YouTube, just like this session will be. So if you need to review any of that, you can go back. But as always, guys, just stop me whenever you have questions. Just interrupt, throw a hand up, or throw a question in the chat, and I'll do everything I can to get you guys caught up. Okay. So suppose that we want to create a simple UI for playing this game. Eventually, within the next few weeks, it would be cool to end up with a simple visualization of the game board. And then once again, some of the transactions we need, we want to be able to start a game. This is kind of an admin transaction. We'll talk more about where the admin part comes in. And then we want a player who visits our front end to be able to mint their ship and pilot token pair. Okay. And if we can provide this successfully, then step 3 would follow. Now that somebody has a pilot and a ship, can they move their ship around? Okay. So last week we left off with a question about compiling parameterized redeemers in Aiken. And this is adjacent to Mesh, and there's actually some stuff that Mesh is going to do for us with a blueprint. That's a work in progress. I know that Hinson has been looking at that, and I've been talking to him about it. And so there's going to be further ways to parameterize validators as the tooling continues to grow. But for now, I was hoping that we could just look at what the current state of the art in Aiken is by trying to compile some of these parameterized validators. And if you're sitting there wondering what's a parameterized validator, by looking at this right now, we're going to have a chance to understand that a bit too. So let me jump into the Asteria code base. That's not it. Jump over here. All right, so Asteria. We've got some on-chain code and some off-chain code. And you can see that, oops, I did grab the wrong window, I'm sorry. Let's get that out of the way. There it is, okay. That's our demo app. Here we go. Here's the Asteria code base right here. All right, let me close all windows for just a second. Let's just review the structure of this project. At a top level right here in the Asteria repo, right? And anybody can copy this. The link, once again, is in the chat. You can clone this locally and start to play with it. We've got the on-chain and off-chain parts right here. The on-chain part is where you're going to see our .ak, right? Aiken files. And the validators are where all the logic is. And in order to create a new Asteria game, we have to use this validator right here. And we can review all this code as we go. Okay, there's a few different endpoints: consume, mine, add new ship, for example. Okay. But at a really high level, the first thing I want you to see is that when we're talking about a validator, that's going to be a function that has datum, redeemer, and context, like you see right here. And validators can optionally have parameters. It's possible to write a validator without these 3 lines right here. It could just look like this. And that would be called an unparameterized validator. But this one has parameters. And you can see them right here. What are those parameters? Well, any instance of Asteria is going to have to define an admin token, which is just an asset. It's going to define a ship mint Lovelace fee, which is an integer. And we can assume from the title, or the name of this parameter, that it's the fee for minting a ship, right? And then this last one, max Asteria mining, is also an integer. And that one's a little more opaque what exactly they mean by that. But at the end of the game, right, when you win this game by getting your ship to the center of the game board, you get to claim some tokens, okay? And this represents the upper limit on how much you can claim there. And we'll see this in action once we get some transactions working. Now, there's a whole bunch of logic right here. And we're not going to have time to read this file line by line during this session. So if you're interested in learning Cardano development, I absolutely recommend spending some time this week getting familiar with the on-chain Asteria code. And once again, the link is in the chat. So I hope you guys have already opened that and you'll clone it locally and start to be able to at least review the code. Now, one piece at a time, we're going to learn how this code works, but the way we're going to do it is by trying to build transactions. Any questions so far? Now, when I'm working in Aiken, if I have a working code base, I can run, for example, yeah, I'm in the right spot. I probably need to be, let's change directory into on-chain. Now let's just do a quick Aiken check. Let's see. Oh, it's in source. Okay, so I just changed directory into on-chain and source, and that's where the Aiken toml file is. You can see it right here. There we go. Let's run Aiken check again. Okay. Oh, looks like there is an error. Looked for mint in space-time. Couldn't find it. Go back to start here. Okay, there we go. I was playing around with a couple things. That's why we got an error before. So I just went back to a clean clone of this repo. And you can see that after I just ran Aiken check, we get this summary down here. It says 64 checks, 0 errors, 0 warnings. Okay, so far so good. Where are these checks coming from? You can see a whole bunch of test results right here. And this is a really, really nice thing about Aiken, how this testing is built in. So you see I ran Aiken check, it compiled the project, and then it looked at the testing directory, tests, right? And it went through each of these test files, which look like this. And it made sure that those tests were passing. And this is, again, this is something that you can learn a lot more about. It's a little bit beyond the scope of what we're going to do with Mesh, but it's a nice thing to know that Aiken does this, and we're definitely going to be creating spaces to learn more about this. Okay. All right, so this is nice, and we will probably refer back to some of these checks as well to help us understand how these contracts work. But at the end of the day, we can say, okay, well, good. There's no errors in the code, and that means we can build it. So now I'm going to run Aiken build. Okay, good. No errors, no warnings. It doesn't run through the tests when we are building. But then you see right here, it says generating projects blueprint, and that's output to this file, plutus.json, which is in the on-chain source directory. And you can see it right here, plutus.json. Now, this is called a blueprint file, and there's a Cardano improvement proposal that specifies what goes into this blueprint right here. But in here, you'll see that we have the names of the different validators. What are they? Well, there's Asteria spend, asteria.spend. That's coming, oh, that's a test, sorry. It's coming from here. Validator, let's close the tests. Asteria spend, there it is. So that's why we can see this name right here. In this file, we might also expect to find space-time dot spend. Let's see if we can find that one in the blueprint. There's deploy dot spend. Here's pellet dot spend. And here's space-time dot spend. All right, so space-time, there it is. Pellet, we just went past that one. Here you go. Deploy, there it is. And of course, where we started at the top is the Asteria spending validator. Now, each of these, the Asteria validator, like I showed you, has parameters. Deploy has a parameter. Pellet has a parameter. And space-time has a whole bunch of parameters. So if I actually want to finish compiling an instance of these contracts, I have to be aware of these parameters. Because watch this. Now that I have run Aiken build, and I have this plutus.json file, what I'd really like to be able to do is build an address for this compiled code, right? Here's the bytes, right? This is the CBOR representation, the bytes representation of the Asteria validator. And if you've studied any kind of smart contracts on Cardano, you know that the goal of writing a spending validator is actually to end up with an address where tokens can be locked, and then those tokens can only be spent if the rules of the validator are followed. Let's try to build an address for this compiled code. We can use Aiken on the command line for this, so I can always run Aiken help to remember how this works. I can compute an address. You see it right here. Aiken address. Let's get some help on that. So it says to use Aiken address, I can specify the name of the validator. This is optional if there's only one validator, but as we just saw, there's 4 validators here. So we will need to specify which one. We won't need to specify the module because there's only one module in the project. Okay, so let's see if this works. Okay, we're not going to specify mainnet yet. We're going to take the default, which is testnet. So let's see. Aiken address -v for validator. And that validator was called spacetime. Well, let's do the Asteria one. Asteria.spend. All right, we get an error. Why do we get an error? Here's the good news. Aiken error reporting is usually pretty helpful. And if we read this, we can start to see exactly why this command didn't work. Why not? It couldn't compute the address of the validator because it's parameterized. I can only compute addresses of validators that are fully applied, meaning all of the parameters are provided. right? This spend validator with its 3 parameters, we need to provide each of those. And then it says 3 arguments. Sorry, I was getting confused. The 3 arguments, that's standard issue, datum redeemer, and context, okay? But the parameters we need to provide right now. So how do we do that? All right, let's see how to do this. It's a little clunky right now. And this is something I've been digging through and really trying to understand better. I pinged a few people this morning and have been just kind of combing through different informal documentation. The standard way that you'll find in all of the Aiken documentation to apply parameters to a validator is to use Lucid, which is fine, but I would like a little bit more control and flexibility over that. Now, if you're wondering what that parameter application looks like in Lucid, you can find an example right here in the Asteria off-chain code. Okay. I think this is where, yeah, we got a spending validator, and this is where we're applying all of the params. Okay. And then the output is your applied validator right here, right? Apply params to this script. So we could do this, and this would be a fine approach. I just want to understand if there are some other ways we can do this. For example, by interacting directly on the command line so that I don't have to write some TypeScript code just to do something that should be pretty quick, right? Throw in some parameters into something. This is something that would be common, for example, just to automate. I want maybe a bash script that can do this very quickly. So I just want to understand the alternatives and have a playbook for doing this. And then with that playbook in hand, if anybody still wants to use the TypeScript, you can still do that. So let's see how this is going to look. Once again, we know we've got 3 parameters: admin token, ship mint Lovelace fee, and max Asteria mining. And these last 2 are integers, int, that's good. This one is an asset class. Shoot, what's an asset class? Well, the good news is in this blueprint, we could see this reference, and it's a reference to a definition that's in the same document. Okay. So we can actually go find this definition down below. Let's try to find it. Asset class. And what if I just search for this? There's another reference to the same thing, another reference to the same thing, another reference to asset class here, another. But here's the definition. What is an asset class? And here you can see this is the actual on-chain shape of this data. So an asset class has constructor 0, 2 fields, a policy, and a name. Okay. So it's a Plutus data object with constructor 0 and 2 byte array fields. Now, what's a byte array? Those definitions are also provided. It's just a string of characters, but let's see if we can find that. Byte array. Bytes. Yeah, just a string of bytes. But here's, okay, so this is where I get a little bit stuck, and this is where just using the existing code would be easier. But this is where I'm at with trying to create like some boilerplate other options for applying these parameters. Okay, so we need to construct an asset class. This asset class, we can see the shape of this like this. Chris, Claudio, do you guys have any experience serializing data types like this in Aiken by chance?
No, remember last year with the PPL, we finished the Aiken at that point because there were a problem with the serialization.
Yeah.
So, but I was wondering, can we just ensure Aiken must provide the mechanism to apply the parameterized validator to the parameters within Aiken, like Plutus does, so we can resolve the problem at the Aiken level and obtain instantiated validator directly in Aiken, and then that just get the seaboard to
I
play
know.
within Mesh.
That's you're exactly right. For me, that sounds like common sense, and the simple truth is it's not yet available. Okay, what Aiken gets us as far as having this blueprint, and then even in the official documentation, it points us out to using Lucid in a Dino project, which for me is a big blocker. I don't want to follow that approach just to apply parameters. So what's the other possibility here? Let me show you. Okay. I can type Aiken blueprint apply. Okay. And okay, now it tells me I find multiple validators. Okay, let me do the one where the validator is asteria.spend. Okay. And now you see what it says. It says it's asking me, it's prompting me, right, in the terminal window for asset class. The problem is now we have to, before we can even do this, we have to serialize asset class into a byte array. And once again, Lucid does all of this for us. It abstracts this away. But I want to have some boilerplate for doing it this way, or even Claudio to write some functions like you're suggesting, where it's just built in, where I don't even need to use this interactive view, or even so that, watch this, I can pass pass a parameter directly, but even to do this, I have to have it already encoded. So I'm getting a little tripped up by all this stuff, and haven't had time to gather the exact playbook for doing this. So yeah, basically that's the blocker we are getting ourselves right up and into during this session. And in a perfect world, I would have already solved this problem, but I'm bringing you guys right up to speed with where I'm at right now. Nelson, have you encountered any of this? Hey, man.
Hey guys. No, I haven't played with this schema yet.
Okay. Okay. I'm realizing I have a little bit more research to do in order to even be able to do this step right here. And that's making me think, just going back to the goals we set, syntax design pattern. This is where we left off last week. And with Catalyst and launching PPBL, I just haven't quite had time to do this. I was playing around with it, but I have not yet succeeded in achieving this goal. Okay. So what I'm going to do here is try to push this back, right? Got a question mark here. So this really is the blocker. Whoa. I've asked Reese and Hinson for help on this. Reese just wrote back that he might have some time to play around with this. And I think Hinson's got a few tricks up his sleeve. But without those, I don't think it's worth spinning our wheels with this right now. And this is going to be temporarily our blocker to this guy. Now, at the very same time, we're working on another example for the Plutus PBL course. This of the faucet validator, where the parameters are a bit simpler, but that one still needs to be tested. Now, of course, this session is about mesh, and we've been spending, I just spent the last half hour talking about Aiken, okay? So I wanted to get you guys up to speed on what the blocker and current work is with Aiken. And now we can set this aside for a moment and go back and look at mesh a bit. Is that okay with everybody? Okay. We'll get to this when the time is right. If I don't solve this problem by next week, we can just skip over this until we do have a really, I want, a perfect boilerplate for everybody that just shows us, all right, here's the easy way to do this. Gonna work on it, but until we have it, I think the best thing to do is now take a step back and start using this time for what we said it's for, which is really getting you guys into mesh development. I know it's new to some people and others are experienced with it. Let's take a look together. What we have is a course. Called Mesh PBL. Let's start from the Mesh website. Okay, so this is Mesh. If you're not familiar with it, it's at meshjs.dev, dropping that into the chat. Okay, and this is a TypeScript library for building applications. There's a whole bunch of documentation. We've looked at this before, and what we now have is the Mesh project-based learning course. The videos, like the one we're making right now, are linked right here to an archive. So you can go back and you can look at what we've been doing since March in these weekly sessions. And then you can also see this link right here, Mesh project-based learning. This is the course that's pretty much ready. And you can see right here, our intention was to release the first 3 modules by now and to have the next one coming out tomorrow. We're going to bump these dates back just a tiny bit. I want to bump this date to this week, okay? Because this module is pretty much ready. Let's take a look. Okay, so the first module, oh, that's why it's not ready, right? It doesn't have the intro, I see, okay. But we do have a set of lessons. In this example, the lessons are about getting your browser wallet set up, preparing your Node.js dev environment if you've never done that, and some basics of React. We're providing this because we're not sure who's going to show up to take this course. Do people who want to be Cardano developers already know how to install a wallet? Do they already have Node.js and some React experience? If not, we're giving them just some basics right here. And if you guys need those prereqs, you saw those are now there. Where the action really starts is in module 101. Think of 100 as prerequisites. That's why that's the title. 101 is where we really get started. And what are we going to do here? We're gonna start by showing you what an application on Cardano consists of and showing you what mesh does and doesn't do. We're going to show you how to add mesh to a new project, how to connect a wallet to an application, view some information about that wallet, use some pre-made React hooks for efficiency. And then you can see this is why it's still a work in progress. So over the next few days, we're going to clean up, make sure the introductions are here, and then just make sure that lessons that aren't there, that shouldn't be there, aren't there anymore. And this is what'll be live. And now, this is what this session time can really start being dedicated to, is we'll make a formal announcement that this content is ready later this week. Then everybody here can start working through it. It's always so helpful to have people who are actually learning this stuff read through the content, because you're the only ones who can really tell us if the content is helpful. If it helps you to learn something, obviously that's great. But if you're getting stuck or confused while working through it, that's on us, and we can help to make that better. So looking forward to officially releasing these within the next couple of days. Yeah, does anybody have any questions about the status of the course or what's coming next?
So I'm new here. How do I know, like, how do I get a notification that they're up? Are there
Great.
any like group chats that I can join or whatnot?
Yeah, do you happen to be on the Gimbalabs Discord server?
I am not, so if I can get that
Yep,
link,
gotcha.
I would appreciate that.
Yep. Yeah, we'll be posting here. And then the Mesh Discord server, let me get you an invite for that one as well. There's a verification step on each one, so just make sure that you find those.
Okay.
And then we will always have an up-to-date list of sessions at gimbalabs.com/calendar. And then finally, the link to the course itself, the mesh course, is the one I just that's on my screen right now. Let me drop this into the chat. And finally, there is the Plutus PBL course. We use the word Plutus, but really it's a generalized intro to Cardano development. So Mesh, if you're a front-end developer, is a really good place to start. But if you're curious more comprehensively about Cardano development, the other course we have is Plutus PBL 2024. This is also in the process of going live right now. Tomorrow, we'll finally have the first module officially ready. It's been mostly done, but we can officially release this tomorrow. And for anybody who's been working on this, Sebastian, Nelson, Claudio, Chris, you guys have been in this. Hey, Lucas, by the way. We're just pushing the release dates back because it's better than starting from behind and always just trying to catch up. This allows us to approach the work a little more calmly. So this module is done. This module is actually almost done, but we got to finish writing it, and now we have a week to do that. So yeah, Alfredo, I hope that's not overwhelming, just throwing a bunch of different options at you, but I really recommend exploring each of these and just recognize these are rolling out in real time right now. So they're a little bit rough around the edges, but that's kind of what's exciting about it, is that we're really just sharing this as we build it.
Yeah, thank you for that.
You bet. Nice, Lucas. That's exciting. So I think for now, this session is kind of an inflection point because we've been looking at Asteria. We absolutely want to continue to do so, but I just wanted to share with you guys some of the blockers that I'm personally dealing with. Um, uh, and it's going to be it's going to be a work in progress to figure out how productive we can be in this live time solving blockers like that, and how much we can figure them out behind the scenes and make these sessions a little bit more dynamic. Okay. So I can't promise precisely when we're going to revisit Asteria again, but what's going to happen over the next few weeks is this. The Mesh course is now live. As we start to advertise it, people will start to look at that. And the number one priority for these sessions will be answering people's questions after they start working through the course. If we start each session like that, giving everybody a chance to ask some questions, then after we have that time, with any time that remains, we can go into the ongoing Asteria work together. And that work is really important to me because we're going to be using it in the course you're looking at right here. When it comes to module 201, building a front end for a Cardano application, Asteria is the example we're going to use for that. Okay, so I'm urgently working on this right now, but apologies for just not quite solving these blockers yet today, and I'll be excited when I do. So does anybody have any questions about what's coming next for these Mesh live coding sessions, or about the courses, or anything else?
Yes, James has a question. So what's your plan on solving this parameters problem? Are you going to address it with Mesh or some other tool? I didn't quite get how you're going to solve this.
Good. Yeah, so there's a few possibilities here. Number one, what I would like to have is crystal clear documentation for how to apply parameters using Aiken on the command line. All right. This is 100% doable. There's just nowhere it's been documented yet. And we're at Gimbalabs, we're used to this. A lot of our Plutus PBL courses have been written by reviewing source code, reviewing Git commit logs, and finally providing some introductory documentation with simple patterns, right? I think this is a major hole in the Aiken documentation right now. That's why we can provide it. So I'm almost there. I was actually working on it all morning today for the last few hours before this session, and I just don't quite have a simple answer that I'm really excited about. Okay, so Claudio, answer number one is to provide crystal clear documentation of how to do this on the command line. But then beyond that, I know that Mesh is working on these kind of blueprint integrations. Hinson has been really kind of doing a lot of work behind the scenes to create some more embedded functionality in Mesh. And once that happens, it's going to get a lot easier. But those solutions are probably about 2 months away right now. And this is another story of Cardano development. You learn how to do things the hard way. And just when you think you understand something, somebody releases a tool that makes your life a heck of a lot easier. And you'll find yourself saying, gosh, where was this tool 3 months ago? But that's kind of the fun of it, right? You'll be able to say you were here before things were easy. So we know that's coming when it exists. We're going to have some really nice examples ready to go for that. And in the Mesh documentation, actually, let me jump over here for just a sec. Let's go back. In the Mesh docs, there's already a guide. Well, it was here. Somewhere in here, there's a guide. They change it? In any case, sorry, the link was here just a few minutes ago. I'm not sure where it is now. There's a guide for using a non-parameterized validator from Aiken in Mesh. They take you through kind of the Hello World tutorial. But there's not yet such an example for this parameterized validator, which is the blocker that I brought to y'all today. So sorry, Claudio, that was kind of the longer answer. But yeah, there's multi-parts, multi-stages. Step one, I just want to have a basic, well-documented pattern. So anybody who doesn't want to install Dino and use Lucid, which is a deprecated library to do this, has an option, because the current state is just, it's not acceptable for people who want to just quickly build a smart contract in Aiken, but then use whatever other tools they want to interact with it. Chris, what do you think?
Hey, good morning. How you doing, everybody? Yes, I'm sorry I get here late today, but so I missed the first part. What I want to ask you is, do you remember before you went to the Builder Fest, the Mesh live session before? We've been working on getting some service providers on the app to be able to show some assets on the app. And my question is, do we gonna continue that that lesson or class? Because I get stuck. Honestly, it works, but the provider doesn't work. You already told me the reasons, but I was trying with Koyos, Block Frost. I know we have Maestro and Ogmios, for example, but I got stuck on that, and I didn't have enough time to be checking the other options. So do we gonna see that again?
Yeah, we'll absolutely go back to that. So just a two-part answer to your question. In the Mesh course, that's going to be covered, let's see. Yeah, in module 102, which will be out pretty soon. We're going to look at just a couple of Mesh providers to get information, okay? And you'll also see it in the Plutus PBL course, the general one, when we look at querying the blockchain. Now, in both cases, the lessons will be there for you, so you can try to do things on your own. But in every course we ever build, we expect people to get stuck. And Chris, what I hope is that you can get yourself as far as you can, get stuck, bring the question, whatever questions you have here. And yes, that's exactly what we'll look at together, and we'll troubleshoot it until you really understand it.
All right, amazing. Thank you, James.
You know it. All right, y'all. Looking forward very much to having these courses really out. We've been working on these for a while, but you guys know there's so many different things going on. But it's finally the week where we can officially release these first few modules, and we'll see these rolling out. So new wave of Mesh Live Coding. We're going to continue, same time, same place, Tuesdays, 1300 UTC, right here on this link. Look for the announcement about the first module being live, and bring your questions next week. We'll keep it going. Thanks, everybody. Take care and hope to see you soon. Cheers.
Thank you.